This is section 2.1, the last page. So far we've just been able to find trig functions of quadrantal angles. Remember, quadrantal angles are where the angle terminates on either the x-axis or the y-axis. Now we're going to look at some trig functions of special angles. So I'm going to start off with an equilateral triangle. And for this triangle, let's make each side length 2. And then I'm going to cut it in half. Do you see if I cut the 2 in half for the base, then this part here would be 1. And then we could find the height. I'll call the height y. By using the Pythagorean theorem. So we have 1 squared plus y squared is equal to 2 squared. So solving for y, we have 4 minus 1 is 3. So y is the square root of 3, and it's just the positive root 3 because this is a distance. So the height is the square root of 3. Now let's look at the angles. If it's an equilateral triangle, and we know the sum of the angles of a triangle is 180, then 180 divided by 3 is 60. So that means that each angle has a measure of 60 degrees. Now since we're cutting this into 2 halves, this angle here would be 30 degrees. Now I'm just going to look at this triangle, the right triangle on the right side of this equilateral triangle. So I'm going to erase this part here. And now let's find the 6 trig function values of 30 degrees. So 30 degrees is our reference angle. And so I'm going to label each of the sides with reference to 30 degrees. We know that 2 is the length of the hypotenuse. The opposite of 30 degrees would be the length 1, and the length of the adjacent side would be root 3. So sine of 30 degrees, we look back at the beginning of this section, following the definitions. It's opposite over hypotenuse, so this is 1 over 2. Cosine is adjacent over hypotenuse, so that's root 3 over 2. Tangent is opposite over adjacent, so that's 1 over root 3. We rationalize the denominator. We can multiply by root 3 over root 3. So we get root 3 over 3. I'm going to use the identities to find the other 3 trig function values, although we could use the definitions too, but just some practice with identities. Remember that cotangent and tangent are reciprocals of each other, so the reciprocal of 1 over root 3 is root 3. Secant and cosine are reciprocals of each other, so this would be 2 over root 3. Rationalize the denominator. And we get 2 root 3 over 3. Cosecant is the reciprocal of sine, so the reciprocal of 1/2 is 2. Now to find the function values of 60 degrees, then our reference angle would be the 60-degree angle. Do you see how the hypotenuse would be the same, but the opposite would now be the adjacent, because we're referring to the 60-degree angle, and then the height is now the opposite. So sine of 60 degrees is opposite over hypotenuse, which is root 3 over 2. Cosine is adjacent over hypotenuse, that's 1/2. Tangent is opposite over adjacent, so that's root 3. And again, some more practice with the reciprocal trig identities. Cotangent is the reciprocal of tangent, so we have 1 over root 3. We'll rationalize the denominator, this is root 3 over 3. Secant is the reciprocal of cosine, so reciprocal of 1/2 is 2. Cosecant is the reciprocal of sine. Rationalize the denominator, we get 2 root 3 over 3. Now, to find the 6 trig functions of a 45-degree angle, I'm going to draw a different rectangle. Suppose that we have an isosceles right triangle. So if it's a right triangle, we need to have one right angle. If it's isosceles, that means that these other two angles have the same measure. If we know that the sum of the angles adds up to 180, if we take away 90, we're left with 90. So the measure of each of these angles is 45 degrees. And I'm going to label each of the legs with length 1. Now do you see how we could find the length of the hypotenuse using the Pythagorean theorem? So we have 1 squared plus 1 squared is equal to r squared, where r is the length of the hypotenuse. So we have 2 is r squared. Solving for r, we get just the positive root 2, because this is a length. So this length is square root of 2. Now, let's go ahead and label these with reference to 45 degrees. So these are both 45 degrees, so it doesn't really matter how you label the legs. So I will refer to this angle, and so we have the opposite, adjacent, and hypotenuse. So the sine of 45 degrees is opposite over hypotenuse, so that's 1 over root 2. If I rationalize the denominator, multiply by root 2 over root 2, and we get root 2 over 2. Cosine is adjacent over hypotenuse, and that's also 1 over root 2, which is root 2 over 2. Tangent is opposite over adjacent, so that's 1 over 1, which is 1. Practice again using identities. The reciprocal identity of cotangent is tangent. Reciprocal of 1 is 1. The reciprocal of secant is cosine. So the reciprocal of 1 over root 2 is root 2. And the reciprocal of cosecant is sine. 1 over root 2, the reciprocal of that is root 2. Let's review a little bit more with cofunctions. Remember when you're working with cofunctions how the sum of the angles is 90 degrees? So if we look back at 30 degrees and 60 degrees, do you see how the sum of these is 90 degrees? Now, sine and cosine are cofunctions of each other. So these are cofunctions. That means that sine of 30 degrees should be the same as cosine of 60 degrees. And you see that's the case. And then cosine of 30 degrees should be the same as sine of 60 degrees. You can see that those are the same. And then tangent and cotangent are cofunctions of each other. So tangent of 30 degrees should be the same as cotangent of 60 degrees. Cotangent of 30 degrees, root 3, is the same as tangent of 60 degrees. Secant and cosecant are cofunctions of each other. So secant of 30 degrees is 2 root 3 over 3, and you can see that cosecant is the same. Cosecant of 30 degrees is 2, secant of 60 degrees is 2. And this is because the angles 30 and 60 add up to 90 degrees. Now, if we look at the 45 degree angle, we know that 45 plus 45 is 90. So the sine and the cosine, since they're cofunctions of each other, should be the same. You see they are. And tangent and cotangent of 45 degrees should be the same, and the same thing with secant and cosecant, because they're co-functions of each other, and 45 degrees plus 45 degrees is 90 degrees.